We looked at equations of circles back in year 9 and 10, back in the day. How do we do that? Yeah, so centered at the origin we got, that one's gone away. That's way better. Okay, x squared we got there with the marker. X squared plus y squared, equals to, I should use the general form, r squared, right? So that's for two variables. Fair enough, right? What's the idea behind this again, right? Just to remind you, the basic idea is that we're using distance formula, and this one's centered at the origin, and we're saying like any point P, x, y, has to be equal to r, right? And when you use distance formula, what you end up creating is, Pythagoras' theorem, and so we square both sides in order to create this equation here. So what might you suspect would a 3D version of this, a 3D circle, a sphere, involve? We have another variable, right? So we have the point x, y, z, and use your intuition here. Like I said, there's a lot of applications of 2D. We're not looking at really vectors exactly right now. We're just looking at coordinates. A lot of applications of 2D coordinate systems that we can apply to the 3D system. And we actually looked at distance formula in 3D as well. It's the same idea. Where we could say that if we want some point P of x, y, z, which is always the same distance from some center, we're going to call it HKL, right? The idea is this. The distance, PC, well, what is that? Remember, if we're using our political correctness in 2020, if we're using this formula, then we can say that x minus h all squared plus y minus k all squared plus z minus l all squared, right? So remember, applying distance formula in 3D is like Pythagoras' theorem with a third variable, essentially. How would we like to write this? Well, same idea. We don't really like the square root in our formula, so we're going to square both sides. And if we let PC equal to r, then essentially we create our equation of a sphere. So formally that's going to be written like this. X minus h all squared plus y minus k all squared plus z minus l all squared equals to r squared. Okay, you jot that down for me. Now, what are the typical equations we do with circles usually? When we move them around, they ask you what's the center, what's the radius. I'm not going to give you one of those questions because that's kind of like an identifying question, right? The other kind of common question they do actually is, okay, yeah, you know what the center is, you know what the radius is, but can you sketch it? So, I mean, are we going to do the same thing here? Not quite, right? Because like I said, it's very difficult to sketch 3D systems. In fact, even as you've seen with the graphing software, it is difficult to interpret it, right? So that's not really within the scope of the course, asking you to sketch these. You could be asked to identify the center and the radius. I think that's pretty self-explanatory. Let me give you this question though. I just said that we're not going to give you a center radius question, but I just did. But this one's been changed slightly. I'm getting judged here, aren't I? This one's been changed slightly. All right, what looks different about this equation? Yeah, right. So the equation of a sphere can be written in this form. But if it's not clearly identifiable in this form, then you can't really work with that. So you can't say conclusively, this is an equation of a sphere with center, something, radius, whatever, right? There's just a whole random jumble of expressions and variables. What can we do about that? Yeah, how do we do that? Completing the cube in the 3D system. We can complete the square on our quadratics here, right? Why don't you have a go doing that for me? What have we got? How do you guys like completing the square with the layout? Do you put the constants on the right side or do you put it on the left side? Some people prefer different things. How do you guys like grouping the constants for this? Do you remember how to complete the square in this, or do I need to refresh your memory?
Yeah, I know how to.
Yep, and guess go.
You have to, what I do is start with the x.
Yep.
And all the x terms together.
Yes, okay, that's what I'd decide as well. So completing the square, I'd put all the same variable terms together. So I'd go x squared plus 6x. I want to actually leave a space there for them. Or did you complete the square in the first? In the first line. Yeah, okay. If you can do that, that's fine. I'll come back to that. I'll just put the variables together first. Minus 4y, and then z squared plus 2z, and then we've got this like 6 going on over here. So that's just chilling. All right, and then we add in our values. So what values do we have?
9.
Yep, so half this guy, square it.
Plus 4.
Yep. And then plus 1. And then did you take them away on the same side? Okay, cool. So there's two things that people would usually do. They either just say, all right, I want to take away, 9 minus 4 minus 1, or they say that's equal to 9 plus 4 plus 1, which is essentially the same thing. It's just two ways of thinking about the same kind of problem, right? Because in one step you move them over to the other side, one step you keep them on the same side. So, I'll just do that. Whichever is easier for you. The other trick with completing the square is that sometimes they keep this as 3 squared, 2 squared, and 1 squared. Because that way, then when you're factorizing it, it becomes a lot easier to do. You just look at like that number. You should be able to factorize that in your head as well, but that's just like another trick to make things quicker, I suppose. So you factorize it like so, and that's what we were expecting. We can move everything to one side here. Matt, what do you get? What is that? Good? 8 or something? Yeah, okay. Right. Sweet. And then that's in our form. R squared is going to be equal to 8, but we need to answer our question here. Our center is going to be... yeah, they tried. That's probably a bit of a hint, hey. -3 to -1. Yeah, they're probably not going to give you like, I don't know, pi or something. Maybe they will. Actually, that is a nice number, hey. Like it's a nice radical. R is going to be the square root of 8, which you could also write as the 2 root of 2 if you wanted to. Okay? Cool. Units, if we so inclined.
Unit test would they want 2 root 2?
No, I don't know necessarily. That's probably like a simplified value. I'd be surprised. Yeah, you wouldn't be marked down on a root 8 kind of answer, right? So that's the question, right? If we want to show an equation is in the form, completing the square is a step we need to use.